Hi. Okay, hi everyone. So, as our previous tutorials, uh, we intro, we give you some basic ideas of these channels and how to start to learn the big data and Hadoop, right? The step-by-step processing to learn the Hadoop frameworks and its tools, right? So, basis of that, this is our first session, and And in this session, we will start with the introduction of the big data, because if we want to learn the big data, first we need to understand that what is the big data, what is the problems of the data, how the big data is introduced, and how they work with the Hadoop frameworks. So that we will learn in this session. So let's see. Let's start. So okay. So let us start. So just I will increase my font first. Okay, so it's Times New Romans. And okay, so before to start, okay, what is the big data, right? So big data is a terms which contain the big data. See, uh, the data here, the term is data. That is very much important. This is very important terms that it should keep in your mind. So this is the very important terms. Each is what? This is the bit data, but the bit with what? The data, right? So what is the data? So normally data is what? Raw fact. As we know, the data is a raw fact, and for storing this data we use what? RDBMS. We know everything, we know this, right? So as we say that data need to store into the, if we have a data, for storing the data in the form of the computer storage system, so we are using any RDBMS tools. Now which kind of tools we have normally used? So normally we use the MySQL, right? Then Oracle, then MS Access, right? So this is all kind of tools they are normally we are using for storing the RDBMS of data. See, this term is very important, that is relational database management system. We are using the RDBMS of data. Okay. Now what our data is, see, should be very much clear. How many, which kind of data we are able to store. So see, so data normally in byte, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabyte, zettabytes, and yottabytes. This is the different kinds of data storage capacity. See, here we are introduced the storage capacity of data, storage capacity of this data. So we are able to store our data by 2 KB or to MB, 2 GB or to TB, right? Then it will be PB, right? So now see, now next thing, see, we will take one example to understand the data first, and how to convert the data into the big data. So let us assume, so if let us assume that we are living into the 1990. See, right? So it's a very the fortunates for us to live into the 19th century, where the petrol price is only in a paisa, right? Right now that is more than 80 rupees. It's very huge. It is also big. We are worried about this big problem of the increase in the petrol price. See, let us forget. So see, we are living in the 19th centuries, and we are just buying the computers. By computers. So what the basic capacity of these computers is? What kind of configuration should we carry with this computer? So normally we have 10 GB of hard disks, right? 180 or might be 64 MB of RAMs, or maximum 128 MB of, because at that times we have a less data, we need less memory to store it, right? Because normally at that time the most of the data stored into the paper, just store, write everything, clip it, store in cupboard. So that sequence is going on at that time, right? So at that time we have a very less data, so that's why our requirement is very less to store into the digital forms, right? Then time to times requirements always be changed. Then the configuration of the computers was changed from 10 to 40 GB, then to 80 GB, then to 120 GB, and currently, recently, if we talking about this 2017-18, our computers carry with the 2 TBs of hard disks. See, this is very important, right? 2 TB of hard disks we are carrying with us for just to store the data, because what? Because we have very large data set, we have very large data. Before a years we haven't, but now we have, and this is very important. Before a year we use the, for recovering, or sorry, for backupping the data, we use the floppy, then CD, then DVD, then pen drive. See, or everyone have this, right? You have the pen drive with the capacity of what? Before we have 1 GB, then it's converted from 2 GB, then it converted from 4 GB, then 8 GB, then 16 GB, then 32 GB. Now we have also 64 GB and even 128 GB pen drive also we have. So, right? Then still we are not satisfied, right? We are not satisfied. Still, if we have 2 TB of hard disk, 64 GB of RAM, pen drives, we are not satisfied. So what we are doing? We are buying some another secondary hard disks, right? So we are use the secondary hard disks. They also has a 2 or 4 TB capacity. See, so suppose we are taking that we have another secondary hard disks which have a 2 TBs, 2 TB capacity. We have a pen drive who has a 64 GB hard disks, 64 GB storage capacity. We have a laptops or computer who have a 2 TB hard disk capacities. By calculating these all things, we have approach 4 to 5 TBs of data storage capacity, but still we are not satisfied. We still have need more space to store the data. Because what is the reason? Because the main reason is our data is increased, right? Now data is increased in which form? That is very much important thing, right? Because the main reason that if we using the data in if we use the, as I told earlier, that data is stored into the RDBMS, and RDBMS is able to process only structured data. We will discuss later on that what is the structured data, but this is, or we can follow it. So it is able to process a tables form of the data which have a column and row, right? Which have a column and rows. But here, as we know that in our computers the maximum space taken by images and videos, right? and still our images is going on, our videos is increased. So our means we have not any fixed size of data, or data is not increased in the any fixed land or in any fixed patterns, right? It is unfrequently it is increased frequently which unpatterns, right? You cannot say that today we have 1 GB of data, tomorrow also there will be a 1 GB data, yesterday also 1 GB, the day after tomorrow also 1 GB of data. No, today you have 1 GB, tomorrow might be you have 1.2 GB, then after you might be a 1.5 GB, and likewise your data always will be increased. This is the big problem right now. See, now see one, let me see one example. So see, this is the figure of the that how many data increase, how many data is generated onto the internet within a minute, within a 60 seconds. See, let's I point out. So within a 60 second, how many data generated in a minute in between the 2017 to 18, within a 9 month, right? So into the 2017s, we have, let me take the example of this Facebook, right? So we have a Facebook here and here, right? So in the 2017s, we have 9 lakhs login per second or per minutes. We have only 9 lakhs login. People's 9 lakhs peoples are logging into the Facebook in 2017 per minutes. But nowadays, in 2018, there is 9 lakhs 73,000 people logging into the Facebook within a minute. Now see, is very important beauty that I discuss right now. So just I will take one calculators. You just understand more. How many users we have in 2017? 9 lakhs. In 2018 means currently we have 9 lakh 73,000 users logging into the Facebook per minute. Let's assume that 9 lakh 73,000 people post something, right? So they put some status, right? So they are just uploading one image. We state one simple example. So they are just uploading a simple image. So 9 lakh 73,000 people uploading the image in a minute, right? Because the 9 lakh 73,000 people log in per minute. So see, within an hour how many image will be uploaded? So just I will multiply with the 60 minute is equal to 1 hours. So within hours there will be a 58 lakhs 5 crores 83 lakh 80,000 images uploaded within a hour. Now assumes in a day 24 hours, in a day that is a millions of data. Now assumes within a year, so now within a day, now we take within a month, multiply by 30, within a years. See, this is the approach figure only of images per users per login. Just upload a single image. We are not talking about the light, we are not talking about the comments, we are not talking about the sharing of the image, just to upload and post it. Here we are also talking about the videos, texts, anything, just images. Now see, within a years or within a minutes, as Facebook said that they have 9 lakh 73,000 login, and they are just posting a single images. So within a years, the millions of trillions of images uploaded onto the Facebook server, right? Now just calculating by the videos, now the calculating by the text messages, right? Now the calculating by the chattings, these all content also remain, right? So now assume that each image, the size of each image is around 10 MBs, right? So this much images we have, just multiply by the 10 MBs. So see, this much storage they required for storing only an images. Now it is possible to store or process this kind of thing or this kind of data into the RDBMS. So the answer is no. The answer is no, because that RDBMS is not able to process this kind of data. This is the big problem. See, this is a big problems. To process this kind of data which frequently, fluently and uncertainty is there. Data with the uncertainty, which haven't any fixed size, which haven't any fixed length, which haven't any fixed patterns, which haven't any fixed frequent to generate unreliable uncertainty with the data, and this kind of data is not able to process by the RDBMS. So this is the problem with the data. So this problem is called the beat problem. It is called as a beat problem. Now see, our word is coming here. Beat problem, and problem of what? Data. Right? The problem of beat problem of the data. So it's called as a beat data because the problem is all about the large data set. Now what is the big data? The definition should be very much clear here. A data which capacity is very large, that is called the voluminous data. Now what is the problem? To process and store in the data. A big data is nothing but a voluminous data set to process and store it, right? This is the big data. Now see, let's see one definitions here. Okay, now see, what is the big data? So big data is nothing but the lots of data. A system enterprise generates a huge amount of data from terabyte to petabytes, even to yottabytes. We already seen the example. This is the older pictures that I put it, so it might be the figure might be changed, but see, this is one example. So the New York Stock Exchange generate 5 TBs in a day, right? The Facebook has 214 billions of photos, which increase around 7 PB per month. See, this is uncertainties. It's not a fix only a 7 PB data. This might be 8 PB, 10 PB, 15 GBs also will be there, right? So this is the big problems with the data. Now the problem we already said that the problem which already I said that a data increased in the voluminous forms, in the very large scale, frequently, fluently, uncertainty, all is there. So the problem is how to process, how to store. This problem is called the big data. So big data is nothing but a voluminous data set for storing and processing it. Now how the big data solve this problem? So big data solving this problem by this Hadoop, right? So we will discuss later on that how Hadoops solve this problem of the big data, right? So now let's say another thing. Okay, so let's see the thing. Okay, so what is the big data? So computing infrastructures that can take, validate and analyze high volumes of data. See, I already told you that is a voluminous data, and data has a any forms, right? So it is a mixed data. It's a structured, unstructured, semi-structured, any kind of data will be there. Now big data has a 4V. They have problems, or we can call the 4Vs of the big data. Very big V's, huh? So that is very important. It's always be asked into the exams or even though in interviews. So what 4Vs into the big data? So the 4Vs is the volumes, velocity, variety, and the veracity. Okay. So volumes. Firstly, that is the volumes. See, this is one video that give you very much clear ideas regarding these four terminology. Okay, what is the volume? So volume is nothing but large amount of data. As we discussed, that data in a very large scale, a very large amount of data is called as a volume of the data. So here you can see the volumes of the data. The thousands of zettabytes of data is increased or generates the scale of this data. This is the scale of. So this is here it is in 2020 we have around 40 zettabytes of data will be generated onto the internet. Have you amazed? The 14 zettabytes of data, how to store? So this is called the voluminous, large scale of data, right? The big data will be generated. The size of data is called as a volume. Now the second point is velocity. We have been already said the data is generated very frequently, unpatterned structure, uncertainties of the data, and the data is generated in a very speedy mode, right? So let's I need to write that the velocity, okay. So volume is nothing but the so the volume is nothing but the large data set, right? The velocity is nothing but the speed of data or unfrequently generated of the data, right? So velocity is nothing but the speed of the data which always be increased, right? The data is always be increased. Now see these examples, your velocity, the now when the data is increased in so much in high way, so the major problem is to analyze the data, right? To process the data and to analyze the data. This is very important task by any data, because at the last what is the objective? To store the data. What is the objective? To store the data into the database or data warehouse or the data mart or the databases. Our major objective to store the data, to analyze the data, to get some by the analysis of the data, it's help us to take any kind of decision in the form in the beneficial of the industries or our companies or our organization. This is the normal thing to store our history of the data, right? We can easy to process as our requirements. This is the normal objective to storing the data. When the data is frequently generated, the major task to analyze that data is very much important, right? So now when we start to analyze the data, we are find out the varieties of the data, right? Which kind of varieties we have. See, these all are the linked together. First, we get the data in very large scale. When we have a very speedy data in a very large scale, so the problem is how to analyze the data. So when we start the analysis of the data, we find out the varieties of the data. Now which kind of varieties we have? So varieties, so we have varieties of the data. So varieties of the data in three forms. One is structure, unstructured and semi-structured. Three kind of data variety. We find out when analyze this data in the velocity. So we find out the three kinds of varieties. Structured data. Now structured data is nothing but a normal data which we are storing into the tables, which have some patterns, which have some column, which have some rows. Every data has some identities. This is called the structured data. Now second one is a unstructured data. Unstructured data means a data which haven't any identities like the images and videos. This is the unstructured data, because we cannot fit that our image is this size of image we have only, this size of videos we have only, because it's unstructured data. You have one image is 1 MB of size, second image will be 5 MB of size, third image will be a 15 MB of size, right? So this is called the unstructured of the data. Third one, that is the semi-structured data, that is called your HTML, XML and JSON forms, which have some structures, but within a structures again that is unstructured of the data. For examples, this is a HTML tag. We have a HTML tag. See, very important. This is HTML tag. This is the body tag. This is a body close tag. Here we have a close tag of the HTML. So this is a fixed format to make the HTML page, but in between this body tag I can return anything. I can return number, I can return the string, I can return the symbol, anything I can return. I can also put in some images, videos, anything. Right? The tag is fixed, but within the tag what I can input, that is not fit. So this is a combination of structured and unstructured data. This is called the semi-structured data. So now see, the big data has a 4 V's. First V, that is volume. We have a large data set, that is a data set which is generated in very speedy mode, very frequently mode. Need to analyze that data. When to analyze the data, we find out the variety of the data, but then now the measure for the problem, that is a veracity. For V, that is a veracity. What is a veracity? Veracity is, we find out in the veracity that a data which generated in very speedy modes, which have varieties of the data, but this data is uncertain. We cannot say it that today we'll write the structure, tomorrow will be a semi-structure, and day after tomorrow will be unstructured. We cannot say it like this, right? Because data will come in the combination of any kind of structures. The structure, unstructured, or might be semi-structure. So this veracity is nothing but the uncertainty of the data. Uncertainty in the form of the size, uncertainty in the form of the speed, uncertainty in the speed of the varieties. Right? So veracity play a major role within this all three V's, because the veracity said the data will be any size, the data will be in any speed, a data will be in any forms. That is uncertainty of the data. So this is the 4V of the big data. See, right? Now the major problem that how to process the data, right? And why do we need to process the big data? Which product is more popular? So this is all the question that is not okay. How to process the data? So what is the normal distributed file systems? So see, suppose we need to read. So okay, up to this it should be very much clear. What is the data? What is the big data? What is the 4 V's of the big data? Now, how to process the data? So normally we are using the distributed file system to process our data. If we have one data warehouse which connected to a multiple client or clients, but data warehouse normally process that data and solve the or save that resource to the multiple users, right? So that is one central machine we have who store all the data within it, and we are just passing our request to the center machine, and that machine will deliver the will give back the solutions as a form of the response. So request and response outline driven to the single machine. Now see what is the problem between the single machine and the multiple machines. So see, if we need to read the 1 TB of data, see this is the thing. So if we want to read 1 TB of data, and we are using the normal distributed file systems. It's a normal distributed file system is what? Now see, let's take one example. Speed. Let's okay. Now see what is the distributed file system. So here, so that is our one central machine. So that is a center machine, right? So center machines, and all we have another different machines which are connected with this center machine. So we have lot many clients, right? So these all machine, right? These all are the different machine which are connected to the one center machine. So these machine are responsible to distribute the data between these all machine, right? So what happens that this all machine just passing the request to this machine for retrieving some kind of data, and on the request this machine will process it and then give the response back to the particular clients. This is a normal distributed file system approach. Now what happens in this approach? All the data stored into the single machine. This is the simple thing, right? And what is the difference between to store a data onto the single machine or to store a data onto the multiple machine, right? So if we want to read, if we take one example to read the 1 TB of data, I want to read the 1 TB of data. So what happens if we have capacity to read 100 MBs of data within a second. So to read the 1 TB of data, and we have 4 IO channels, so within to read the 1 TB of data we require 45 minutes onto the single machine. But suppose we are storing this data onto the 10 different machine, and now we want to store, or now we want to read the data. So again the same thing, each machine that is 4 IO channels and the capacity of 100 MB of data in a seconds to read from the computers. But here we have 10 machines, so on a single machine we suppose it take the 45 minutes, so within a 10 machine it will be a 4.5 minutes. This is the important task done by the big data, because the major task is just to store is not important, need to process the data, right? Because we have very large scale of the data. If we are storing the data but we are not able to process the data, it is useless, right? So here we need to store the data, we need to process the data, and for doing this task, for doing storage and process the data, process the bit data, we have Apache Hadoop. We have a Apache Hadoop which help us to store the data and process the data. Now we just take one introduction session of the Apache Hadoop. So what is the Apache Hadoop? So Apache Hadoop is basically a framework that is based on Doodle file systems and Doodle map reduce. We will discuss later on that what is the map reduce and everything. So it is introduced by the Docker team. See, the Hadoop, originally the Hadoop introduced by the Docker teams. It is the main authors to make these Hadoop frameworks. The Hadoop is nothing but the open source software frameworks for storing and processing the large scale of the data set onto the clusters of commodity hardware. Commodity hardware is nothing but the normal hardware that we are using in our normal desktop or laptops. What we are using. So this is called the commodity hardware which do not require any large configuration. Normal configuration that we are normally using. That is a commodity hardware that we are discussing later on what is the Hadoop and everything, right? So now the Hadoop is able to process and store in the data onto the large scale. Now how to do that by the Hadoop? So for store the Hadoop have a concept is called the HDFS, the Hadoop file systems, Hadoop distributed file system, and for process they have a concept of map reduce. So Hadoop has a two major concept, the HDFS and map reduce, for storing the data and the processing the data. Even though Hadoop has some frameworks which have also another tools which help us to store and processing the data, that we discuss step by step. Now how to configure the Hadoop and how we are using the Hadoop in this tutorial. So Hadoop basically configures by manually by the you can download the Hadoop from the Apache software and configure it into the any Linux based operating system. If you want to use the Hadoop into the Windows machine, so you need to use the virtual machines on your Windows, and into the virtual machine you need to load the Hadoop. Normally in our tutorials we are using the Cloudera for performing every task and operations of the Hadoop related file systems, right? Like the HDFS, speed, MapReduce, Hive, Scoop, everything we are performing onto the Cloudera. So in the next session we will discuss that how to configure the cloud, how to install the clouds, how to run the clouds, and what is the basic requirement to use the Cloudera machine on your laptops or on your desktops. So that we discuss later on. So up to that we are very much clear that what is the big data, what is the Hadoops, and what is the data, what is the big data, what is the for V's, everyone that we have been discussed right now, right? So today just I finished my session. I hope you enjoyed a lot, and in the next session we will as we already told you, in the next session we will start to what is the Hadoop, what is the HDFS, what is the MapReduce, and we will see in the details of the HDFS and MapReduce and the clusters, everything we will discuss in a very much details into the next session. And even though we are also making another videos regarding the Cloudera, how to install the Cloudera on your local machines, and how to work with the Hadoops with all the redundant tools as well, right? So that we discuss later on. So up to today, we hope you are enjoying like this session. So hope you will share these videos, you will subscribe this channel, you will like this channels, everything, right? So thank you and bye.